Hello everyone, welcome to another video. So in today's video, I have another set of very important AWS DevOps interview question and answers. All these questions have been asked from me in various DevOps interviews in the past. Okay, so these are very important questions, and I think if you want to appear for any interview, be it for AWS Cloud Engineer or a DevOps engineer, or even site reliability engineer, you should be prepared for these questions before an interview. Okay, and whatever information I'm showing you here, whatever theoretical, whatever theory is given in this PPT has been taken from AWS's official documentation. So I'm trying to keep it as authentic as possible. All right, so let's start. So question number 1 is, how do you design a highly available and fault tolerant architecture for an application in AWS? First thing is, you should know that highly available is also called HA. Sometimes interviewer may use these terms, and fault tolerant can also be called as resilient. Okay, so in this question, if you see, the interviewer hasn't given me any specifics like what kind of application is he asking for, or what kind of architecture, what kind of services I should be using to design this application architecture. Okay, so in these cases, you have to keep the answer as generic as possible. Okay, so if I talk about the answer, so before deciding on a HA and fault tolerant architecture, we must understand the tolerance levels of RTO, that stands for recovery time objective, and RPO, which is recovery point objective. Now these two are very important terms. Okay, sometimes interviewer may ask about these terms only, so you should have a clear conceptual knowledge about these. So let's talk about RTO first, which stands for recovery time objective. It is also called downtime. So this means that if an application goes down, okay, then how much downtime for that application is tolerable for the company's business. So that's called RTO. Okay, so and if I talk about RPO, which is recovery point objective, it refers to loss of data. So for example, there's an application which goes down at 9 a.m. in the morning. Okay, and to recover the application, you have to go back in time and you have to restore from the last backup. If that last backup happened at 8:30 a.m. okay, so you know that you don't have the data for half an hour. From 8:30 a.m. to 9 a.m. you don't have any backups. So so this is called data loss, and this is your recovery point objective. Means you are so in this case, if we assume that you are taking hourly backups, which means that if a backup is taken at 8:30 a.m., the next backup will be available at 9:30 a.m. So if the application goes down between this period, then it must be acceptable for the business. So this is your recovery point objective. In our case, the example that I gave, you have lost only half an hour of data, which is tolerable as per the RPO limit. Okay, so why I'm using these two terms? Because whenever you are designing any HA and resilient architecture for an application, the more the more reliability you want for your application, you have to pay more as well, right? Because it is attached to cost. So you should clearly understand your company's RPO and RTO objectives, and accordingly you have to design your application's architecture so that it is highly available, fault tolerant, and you're taking care of your budgets as well. Okay, so cost is also one of the factors in this. So that's why I introduced these RTO and RPO terms. I hope it is clear to you. So this is about it. Now if I talk about how do you design the HA and resilient architecture, if you know your RTO and RPO objectives, the next thing is always try not to have a single point of failure, whatever it is. means to deploy the application. Sometimes applications are called workloads in multiple availability zones. I think we have already seen this in one of the hands-on project that I did. But anyways, so so you have to design the architecture in such a way that you are using multiple availability zones for disaster recovery. So in case any availability zone goes down, you have other availability zone or zones to serve the traffic for the users, okay, without impacting your application. Or maybe application is impacted, but the performance goes down, but still the application is up and running. And yeah, so it depends on what you want to achieve, but it is better to have your this architecture deployed in multiple availability zones. Okay, next, if we talk about, we can use elastic load balancer. So this first statement was like a general statement that to have your this application architecture deployed in multiple availability zones. Now if I talk about the resources that can be used to achieve this, so we can use elastic load balancers for fault tolerance. As we know, when we create any ELB, we get to use 2 or more availability zones, and ELBs are going to perform health checks on the target instances or the target machines that are attached to it. And if and only if the health checks pass, only in those cases the client request from the load balancer will be passed to the targets, else the traffic will be routed only to other instances which are healthy. Okay, then if I talk about other resources, we can use EC2 AutoScaling groups for high availability. So AutoScaling groups, again, it's a combination of multiple EC2 instances which you can use to achieve high availability for your application. And if one of the instances fail by any reason, if the health checks fail in any of the instances which are part of AutoScaling groups, in that case AutoScaling group is going to try to create another instance to achieve the desired capacity in your AutoScaling group. Okay, then one more thing that I want to include here is use of any IAC tool or infrastructure as code tool to script your infrastructure. Why I'm saying this? Because in case of any disaster, okay, in case your entire application goes down, if you have scripted your infrastructure using a scripting language like if I talk about AWS, you can use CloudFormation, okay, which is a very popular one. But these days you are hearing names of Terraform and Crossplane as well. So if you have a script of your architecture, you can always redeploy. You can just just execute the script and you'll be able to create your entire application architecture as it is. Okay, so this is again one of the best ways to have a disaster recovery mechanism for your application, to have a script that is going to create, or I can say recreate, your entire application architecture. All right, I hope the concepts around highly HA and resilience are clear. So RPO, RTO are very important. Okay, and then you have to understand, then you have to mention the use of ELBs, ASGs, IAC, and also you can talk about the use of multiple AZs. Okay, I'm taking some extra time here, but it is totally worth it. Okay, so next I just want to give you an example of how to design an application architecture. So as I mentioned, all these informations, all this information has been taken from AWS's official documentation only. Okay, so in this example, what I want to show you is, suppose you have an application that is hosted on an EC2 instance. We are using AutoScaling group with an application load balancer, and we have 3 availability zones here. Okay, now at a time, to achieve the desired performance of your application, you need 3 instances. Okay, so if you need 3 instances, and if one availability zone goes down, okay, so your one of the 3 instances goes down, and if for some reason your scaling group also has some issues and it is not able to create a new instance. Okay, so then in that case, if you see, your application will still be served by the 2 availability zones here, but your performance will be downgraded, right? Because you need 3 instances to run at all the times to serve the traffic, right? To have the desired performance of your application for the customers. But in this case, since you had 3 instances in total, and if one goes down, and then AutoScaling Group also has some issues, in that case you will not achieve your desired application performance. This is one of the scenario. Okay, so to achieve the desired performance, okay, even if like this entire availability zone fails, or if this auto scaling group also fails, in that case, how can you achieve the desired performance for your application is given in this architectural diagram. So here, if you see, what I have done is, now in this example, just assume that you need 4 instances to run at all times to have the desired application performance. Okay, but you have provisioned 6 instances. Okay, why? Because in case of any availability zone failure, or in case of any auto scaling group issues as well, in that case also you will always have 4 running instances to have the desired application performance. Okay, so what I meant by showing you these 2 diagrams is, to have better resiliency and high availability for your application architecture, you have to pay more. You have to over provision your infrastructure most of the times, so it's going to incur some additional cost. So it depends on cost also, how much highly available and resilient architecture you want for your application. Okay, so this type of architecture that you're seeing on the screen is called static availability. Okay, because no matter what happens, you are still going to get the desired application performance for your application, but of course you have to over provision your infrastructure in this case, because you only wanted 4 instances, but you are using 6 instances at a time. All right, I hope the concept of HA, fault tolerance and cost are clear to you now. Any doubts, you can always reach out to me. All right, question number 2 is, now once again, this is a very simple question actually, but sometimes people don't know the answer to this question as well, so I just wanted to cover this up here. So what is the default routing algorithm of an application load balancer? Which other algorithm does it support? I've already covered this in my ELB video, but let's just see the answer here. So default routing algorithm is round robin, and the other option is least outstanding requests. So this is a very important question, and you should really know the answer of this question at all times. All right, so that's all for this question, nothing much. Let's move on to the next question here now. Which load balancer is most suited when you have to handle millions of requests per second? So we can use network load balancer, which is better suited to handle millions of requests per second with ultra low latencies. Okay, so this load balancer has been designed in such a way to to be able to handle these millions of requests per second. So remember this, it will be a network load balancer and not application load balancer. Also, another question that I did not mention here but can be asked is, when you want, when you have an application that requires a static IP for your load balancer, in that case also network load balancer is going to be the better option, because it can sustain the IP address, so it can use static IP addresses. Okay, next question number 4 is, how do you support extra read requests in RDS? Okay, RDS stands for Relational Database Service, which is a fully managed service by AWS to manage your database instances. Okay, so how do you support? Here what the interviewer is asking from you is, if you have one RDS instance which is getting some extra read request or high user request of your database instance, how high read request for for your database instance. So how do you handle this in RDS? So to support these extra read requests, you can use the concept of read replicas. Okay, so read replicas, you can create copies of your primary RDS database instance. Your primary RDS instance is also called the writer instance, because the data is written to this node or this database instance. Okay, but if you have the need to create to support the extra read requests from the users, in that case you can use the concept of read replicas, which is going to create the copy of your primary instance to offload read requests from the primary instance. Okay, so what happens, the data is copied asynchronously to the a copy of the instance, and in most cases you can have at least 5 read replicas of your RDS instance. Okay, of course, there are some exceptions, but I'm just talking about a very general scenario. So to support the extra read request, you have to create read replicas of your database instance. Next is once again it's related to RDS. So how do you achieve disaster recovery in RDS instance? For that, the concept is multi-AZ. So using this multi-AZ feature, you can enable this multi-AZ feature for an RDS instance. So what it's going to do, it's going to create once again it's going to create a copy of the primary instance in another availability zone. Okay, in case of a failure, the traffic is automatically routed to the secondary instance, and the data is copied synchronously here. So remember this, in case of read replicas, the data was copied asynchronously, means there is a slight lag in the data between your primary instance and your read replica. But in case of multi-AZ, the data is copied almost instantly. Okay, this is because if your application if your database fails for any reason, you have to switch the traffic to the standby instance instantly. Okay, so the data should be exactly the same in both the database instance nodes. Okay, and one more thing I just want to mention here is, when you have this multi-AZ feature enabled and you have standby instance, that standby instance cannot be used to serve your extra read requests. Okay, it is only there to support the failover. Remember this also. Okay, so yeah, so just wanted to include this information as well. Next, what is cross-zone load balancing? So if you remember the video that I did for ELBs, so I covered this attribute of load balancer, that is cross-zone load balancing. Okay, I think I did not give it, I think I did not give too much detail at that time, but let's cover it here. So I'll just give you the example of when the cross-zone load balancing is enabled for your load balancer and when it is disabled. What is the difference between the two? Okay, so you can go through this theory part when you have access to this PPT, but I'll just give you the example of these two diagrams here, which this theory is about these two diagrams only, but I'll just explain it in my own words. So this first figure that you see is when you have cross-zone load balancing enabled for your load balancer. So what generally happens in an ELB? So all the traffic that is being routed to your ELB, okay, it's going to divide that particular traffic equally to all the availability zones that it has its node in. So in this figure, if you see, we have two availability zones with this application load balancer. So whatever traffic is being routed to it, it's going to divide the traffic equally to both the availability zones. So which means 50% here and 50% here. But since we have enabled cross-zone load balancing, so what it's actually doing, it's equally distributing the traffic to each node. Okay, I'm sorry, to each instance which is part of the target of this application load balancer, equally to each instance irrespective of the availability zones here, because we have enabled this cross-zone load balancing. That means the traffic will be equally distributed to all the instances of this load balancer target group. Okay, but in case we have not enabled this cross-zone load balancing, in that case some of the nodes will be overloaded with the request, and some of the nodes or some of the EC2 instances will have very less number of requests, because you have not enabled cross-zone load balancing. So this is actually the more ideal way of using an application load balancer, to enable cross-zone load balancing, so that each of your targets which are part of your application load balancer gets the traffic equally distributed. So here if you see, it's saying 10 10 10 for each, which means if you just count, it is 10 different EC2 instances, and each instance is getting 10% of the request, which means the traffic is equally distributed on EC2 instances. But in case of this scenario where you have disabled cross-zone load balancing, if you see, then 25% traffic is going to one instance, and the other 25% is going to one instance, because these are in one availability zone, and rest of the 50% is going to 8 different EC2 instances, which comes out to be 6.25% on each EC2 instance. So this is not the ideal way of distributing the traffic from the application load balancer. So this is the concept of cross-zone load balancing. Okay. Next is question number 7. How an EC2 instance in an auto-scaling group is replaced based on the health checks. So once again, I covered this in my auto-scaling group video, but let's just repeat what was covered there as part of this question. As part of the answer to this question. So an auto-scaling group, how it functions, it continuously monitors the health of each instance that it is counting as its part, right? So all instances in an auto-scaling group starts with a healthy status initially. Instances are assumed to be healthy unless Amazon EC2 autoscaling receives a notification that they are unhealthy. So the instance status will always start with healthy, and it will wait for any notification from any of the sources that reports any instances unhealthy. Only in that case it is going to try to replace it. Okay, now from what resources or from what sources it can get the notification that the instance is unhealthy? It can use Amazon EC2. So if you know, in Amazon EC2 we have two types of health checks. We have system status checks and instance status checks. System status checks means the checks that are done on the hardware or the host of your instance. Okay, so if that check fails, in that case EC2 is going to report to AutoScaling Group that a particular instance is unhealthy, so please replace it. So AutoScaling Group is going to replace that instance to maintain the desired capacity of the AutoScaling Group. Similarly, the other type of status check is instance status check, which checks the status of your virtual machine or your instance. So once again, if that is unhealthy, then EC2 instances again is going to report back to ASG to replace that particular instance. Similarly, if you remember, in ELB also we can configure health checks. So if any ELB health check fails, then once again it's going to, it can report to ASG that a particular instance has failed the health check, so please go ahead and replace it. So once again ASG is going to try to replace that with a new instance. Then similarly you have other resources that can be integrated with your AutoScaling Group, like VPC Lattice. It also can report failed health checks for a particular instance. So it can also send a notification to the AutoScaling Group to replace a particular instance in the group. Similarly, EBS also performs its own health checks, which are generally based on input-output operations. So if EBS also reports an unhealthy storage, then the storage, the instance that is attached to that storage can be marked as unhealthy, and once again ASG is going to try to replace it with a new one to maintain the desired capacity. Similarly, you can also have your custom health checks as well if you want. So those health checks can also send a notification to the AutoScaling group that a particular health check has failed, and please try and replace the instance with a new one. Okay, so next is when an in-service instance becomes unhealthy, it is replaced with a new one to maintain the desired capacity of the group, as I just mentioned. So these are the different sources by which AutoScaling group can be informed of an unhealthy instance, and it will try to replace it to maintain the desired capacity of the group. So this is a very important question again, and it was asked for me long time ago, and I was not able to answer it properly, frankly speaking. So I just wanted to cover this here in this video. Next is, what are lifecycle hooks in AutoScaling groups? So let's just understand the concept of lifecycle hooks. So a lifecycle hook lets you perform some custom actions on instances. Okay, it provides you a specified amount of time, which is 1 hour by default, to wait for the action to complete before the instance transitions to the next state. So there are two examples which I also mentioned in my AutoScaling group video as well, but let's just repeat what we learned there. So so these two are the use cases of lifecycle hook. Okay, so generally it means that you can perform some custom action, you can run some custom script on an instance before the instance is getting terminated, or before the instance is getting launched, or it is getting ready to serve the traffic. So you can do some custom actions. But if I talk about use cases, so a use case number one is when a scale out event occurs. Meaning of scaling out is that the number of EC2 instances in AutoScaling group will be increased. Okay, will be increased. So when a scale out event occurs, your newly launched instance completes its startup sequence and transitions to a wait state. If you're using this AutoScale, if you're using a lifecycle hook in an AutoScaling group, so you can what you can do is you can keep the instance in the waiting state, okay, for a bit, and then you can run a script to download and install the needed software packages for your application. So why are we doing this? Suppose there's one instance which needs some additional softwares to be installed, okay, before it can start to serve the traffic from the users, and those installation takes some extra time. Okay, so what you want for that instance is that instance should wait for that script or those software packages to be downloaded successfully. Only then it should start to serve the traffic, else the requests from the users are going to fail and the users may get impacted, right? To avoid that, you can create a lifecycle hook, and you can keep this instance in a waiting state, which means the instance is not ready to serve the traffic. So you can run your this script, your custom script, and then the instance can be can get ready to serve the traffic after the script has successfully executed. All right, so when the script is finished, it's going to send the complete lifecycle action command to the to continue. So which means that after you have successfully executed the script, you can use it to you can use the instance to serve the traffic now. So this is one of the use cases. The other use case is when a scale in event occurs. Scale in event means when the instance is getting terminated. So a lifecycle hook can pause the instance before it is terminated, and it can and you can send a notification using Amazon Event Bridge, which is another service in AWS which you can use to send notification while the instance is in a wait state, because this particular instance is about to get terminated, but since you are using a lifecycle hook, it's going to be in the waiting state for a bit, and then you can once again you can invoke an AWS Lambda function or connect an instance to download the logs or other data before the instance is getting fully terminated. So the use case here is there's an instance which is about to get terminated since it has some issues, but you want to understand the root cause of that issue. So what you're trying to do is you're trying to use a lifecycle hook to pause the instance to a waiting state, and you want to run a script which can download the logs from that particular instance and send it over to you, and then the instance will get terminated. So in this way you can collect the logs of a failed instance before termination. So this is another use case of a lifecycle hook. Okay. Then question number 9 is, how do you peer two VPCs? So basically, interviewer is asking what is VPC peering. Once again, a very important networking concept and used in most of the organizations where you are using AWS VPC. Okay, so let's look at the answer to this question. So a VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using private IPv4 addresses or IPv6 addresses. Okay, so basically, if you see in the diagram, we have two VPCs, VPC A and VPC B. Now, by default, VPC A cannot talk to VPC B and VPC B cannot talk to VPC A. This is the default behavior of a VPC, right? But in case you have some requirement wherein you want to want these two VPCs to be able to talk to each other, in that case you can create something called as VPC peering connection. Okay, so what happens in VPC peering connection? You are able to connect the two VPCs so that they can route the traffic from one way to the other and vice versa. Okay, so once again, if you see in the theory that is mentioned in green, so you can get a VPC pairing connection between your own VPCs, or you can have a VPC in another AWS account as well, or you can have a VPC in another region as well. So that is called inter-region VPC pairing connection. Now, to create this pairing connection between two VPCs, so there are certain steps that you have to follow. So those steps are, first is, for example, VPC A wants to pair to VPC B. So then VPC A is going to send a pairing request to VPC B, and then VPC B needs to accept the request to get paired with VPC A. Then whatever routing tables are linked here in both the VPCs, so those routing tables have to be updated with the route to include the CIDR range of the other VPC. So for example, if VPC A has route table A and VPC B has route table B. So in route table A, you have to add a route to include the CIDR of VPC B. Similarly, in the route table of VPC B, you have to include the CIDR in the route to VPC A. Okay, so these configurations have to be bidirectional always. Similarly, whatever security groups are involved, you have to reference the peer security groups, which means that if you have a security group that is attached to an EC2 instance in VPC A that wants to communicate to EC2 instance in VPC B, then the security group should have the security group of the other VPC reference in the security group rules. Okay, similarly for VPC B, you have to do the same. So all the things, all the steps have to be performed bidirectionally to be able to have this VPC peering connection connected successfully. Okay, so after referencing the peer security groups, now once again, to enable VPCs to resolve public DNS host names to private IP addresses, DNS host names and DNS resolution in both VPC should be enabled. So generally we have two settings in any VPC, and these two settings are generally enabled. Okay, but in case it isn't, then you have to do so. So you have to enable these two settings in both the VPCs. Okay, DNS host names and DNS resolution. Okay, and then the last step is to enable DNS resolution in the peering connection as well. So when you have created this peering connection, okay, it has been accepted by the other VPC, you get one peering connection. If I can show you. Okay, so if I can show you this, how does this VPC peering connection option looks in an AWS management console. So I'm logged into my AWS account, and I'm on the VPC dashboard. Okay, So here you can see on the left hand side, you get something called as this peering connections. So when you've created a peering connection, within this peering connection settings, you have to enable this DNS resolution as well for the peering connection to work. So all these steps are important to create a successful VPC peering connection. Okay, I hope the concept is clear to you. Once again, a very important networking concept in AWS. And the last question is, what are VPC endpoints? Okay, so let's see the answer. So a VPC endpoint enables customers to privately connect to supported AWS services and VPC endpoint services powered by AWS Private Link. So before I talk about VPC endpoints in general, let me explain the concept of AWS Private Link to you. Okay, for that I have created one architectural diagram that I want to show you. So what is an AWS Private Link? So AWS Private Link is a technology that is used in AWS to do a specific task. Okay, so to explain that, suppose in an AWS region, you have your VPC, VPC. Within the VPC, if you create interface endpoints, okay, I'll talk about this. Okay, so just assume that within your AWS region, within your AWS account, within the region, you have created one VPC, and in a VPC you have created VPC endpoints of type interface. Okay, now if you want to talk to S3 service in your AWS account, where this particular VPC also resides. Okay, so generally when you create an S3 bucket, and if you want to access it, the default endpoint of an S3 bucket is a public endpoint. Remember this. Okay, so I mean, by default, if you want to access an S3 bucket, it has to be accessed using a public endpoint, which means it has a public IP attached to it. Okay, but of course, whenever we are using these public IPs, it is not the most secured way of accessing any resource, right? To avoid that, what you can do is you can use the concept of AWS Private Link to create a VPC endpoint. Within a VPC, what it's going to do, it's going to create another endpoint which is going to be private for a particular resource, for example S3 bucket, and then you can connect to this S3 bucket on a private endpoint instead of the public endpoint, which was the default, which is default for an S3 bucket. Okay, so the main concept here is you are using this AWS Private Link technology to create a VPC endpoint. Okay, that is going to give you a private endpoint to certain resources, which by default are accessed over public internet. Okay, so I just gave you the example of this S3 bucket. Similarly, if you have some AWS services in another AWS account that you want to access privately, in that case also you can use the concept of AWS Private Link, which means you can use the concept of VPC endpoints. Okay, now if I talk about another example is if you want to connect to a third-party VPC. This third-party VPC here, it generally means, if you've heard about AWS Marketplace, so AWS Marketplace is once again is another service. Okay, so it is actually called third-party VPC. So if you have a requirement where you want to connect your resources to this AWS Marketplace resources, okay, in that case you can use the concept of VPC interface endpoints, which means that you will get a private connection to connect to this third-party VPC. Okay, so these are some of the cases in which you will use this AWS Private Link. So this is the concept of this term here, which is given here. Now let's talk about this VPC endpoints in general. So VPC endpoint, as I mentioned, it enables customers to privately connect to Supported AWS services. When I talk about supported AWS services, I mean these services which I just spoke about. For example, S3 bucket, which is by default accessed on public internet, but you can use the concept of VPC endpoints to have a private endpoint connected to this, and you can use it to connect to it. So this is actually more secured way of accessing a resource. Okay, so this this particular technology is used to have better security of your resources, and also it has speed as well. So you get security, reliability, and speed to access certain resources privately. Okay, I'm using the concept of endpoints. So you can use this AWS private link to create the endpoints to access your resources privately. Then if I talk about what generally happens when you use this endpoint, so Amazon VPC instances do not require public IP addresses to communicate with resources of the service, which I just spoke about, that you don't need any public endpoint or public IP address to connect to these resources. You can use this private link resources. You can use this private link endpoint to connect to the different resources. So traffic between an Amazon VPC and service does not leave the Amazon network, which means it's not going to go to public internet. The traffic is going to remain within AWS. Okay. Now, if I talk about some of the features of VPC endpoints, these are the virtual devices scaled horizontally, and they are highly available and fully managed by AWS. So we have two types of VPC endpoints. One is called VPC interface endpoints, and other one is VPC gateway endpoints. So the example that I just showed you is an example of interface endpoints. Okay, so only and only interface endpoints uses the concept of AWS private link. Okay, and not the gateway endpoints. Okay, so just remember that gateway endpoints does not use a private link to function. They have some other method that we will see in this PPT. Okay, so let's just read about this definition of interface endpoint. An interface endpoint is a collection of one or more ENI or elastic network interfaces with a private IP address that serves as an entry point for traffic destined to a supported service. Okay, so if I talk about services, I'm talking about these services. So this is an S3 bucket. This is some other services in other AWS account. These are also called endpoint services, and third-party VPC, which I'm referring to an AWS marketplace. Okay, and whatever services are supported by AWS private link or interface endpoints is given in this documentation that you can go through. So this is about interface endpoints. Now, if I talk about gateway VPC endpoints, so this gateway VPC endpoints, it provides reliable connectivity to Amazon S3 and DynamoDB services without requiring an internet gateway or a net device or a net gateway for your VPC. So gateway endpoints do not use AWS private link, as I just mentioned, unlike other types of VPC endpoints, which is interface endpoints. So let's just understand the concept of gateway endpoint as well. So for that also, I have created one diagram that I want to explain you. So if I go to gateway endpoint tab here, so when we are not using the concept of gateway endpoint, how the traffic is flowing. So let's understand that. Okay, so in this example, I have this Amazon S3 bucket, and I have this DynamoDB created here. Okay, so if I'm not using the concept of the gateway endpoint, in that case, how the traffic is going to flow? Suppose you have an EC2 instance which has been created in a public subnet. Okay, so which means that this instance is going to have a public IP. So to connect to other services, for example, this S3 bucket, which has a default public endpoint to access, in that case, this instance is a traffic has to go out of internet gateway to connect to this S3 bucket. Okay, so this is the default behavior, right? Because this instance is in a public subnet himself, itself. So it's going to use internet gateway to connect to the S3 bucket. Then if I talk about instances in the private subnet, since we do not have an this NAT gateway here or any this netting device here in this diagram, so the instances in the private subnet cannot talk to any service which are which have this public endpoint. Since to do that you have to create a NAT gateway. So using a NAT gateway which will be created in this public subnet, this private subnet can route the traffic to this NAT gateway, and then from a NAT gateway the traffic can be routed to internet gateway, and from there to these services. So this is how the things work, right? So this is the default behavior. But if I talk about the concept of gateway endpoints, how to use gateway endpoints to have better security, okay, then better reliability and better speed of your traffic. So how we can use it, that is shown in the second diagram. So here if you see, I've given the example of EC2 instances which are in the private subnet. So here if you see, the main concept was to have a connection to your private resources, okay, privately connecting to other services within your AWS account, okay. But in this case we have to create a NAT gateway. So once again, NAT gateway is a resource that is created in a public subnet, and then NAT gateway will use this internet gateway to connect to these services. So you are using some public IPs here, which is not the most secured way of accessing a service. So that is why we have this concept of gateway endpoint, wherein the instances in this private subnet can connect to these services on a private connection. How? Using the concept of gateway endpoint. So how this gateway endpoint works? You make an entry in the route table of the VPC, okay, and that is going to point to this VPC gateway, and from there the traffic will be routed to these services. But this type of traffic does not need any NAT gateway, okay, and it is fully private. So it has all the resources that are being used have a private endpoint, and there's no public endpoint here in this example, in this scenario. So that is why we use gateway endpoints, and we try not to use our internet gateway or NAT gateway, since it uses the public endpoints. So this has more security, reliability and speed of your data. So this is the preferred way of accessing this S3 bucket or DynamoDB service within your AWS account. So this is the concept of gateway endpoints. So this gateway VPC endpoints, it provides reliable connectivity to Amazon S3 and DynamoDB without this Amazon S3 and DynamoDB services, without requiring an internet gateway or a NAT device for your VPC. Okay, so these gateway endpoints do not use AWS private link, but it uses an entry in the route table of the VPC to connect to these two services on a private connection. Okay, so I hope all the questions were clear to you. I took some extra time because I wanted to explain it in every detail possible. So I hope this video was useful to you. If it was, please hit the like button. Please share this video with your friends and colleagues, and please do subscribe to my channel so that I keep making these videos in the future. Alright guys, that's all for this video, and I'm going to see you in the next one. Bye.